Alright, hey everybody, hope you're all having a great day so far. Mine has been pretty good. Had to take my doggy to get her yearly shots, but that went pretty well, and besides that, it's been a pretty boring day. But yeah, let's start programming. Okay, so I know yesterday I said that I was gonna be done with this project, but like almost immediately after I went off, I realized that there is a way that I can maybe bring down these render calls just to 1 using a new shader and some other information I've learned about shaders over the course of this project. So let me pull up the Unity help file about this. So basically, using these blend modes, you can, well, you have to use the Z-write and then Z-test, and what we want to happen, usually the camera uses something called the depth buffer, and the depth buffer reads every polygon that it's rendering and only renders, well, the gist of it is it only renders the polygon that's closest to the camera. So if you turn off Z-write and the Z-test, then it will actually render every polygon, which is what we want to happen, and then each shadow mesh will be a specific color, and then using these blend modes we can decide how the graphics engine will combine the colors of the different masks if they overlap, and that was always the issue that I was having. But now that I understand blend modes better, it is possible that we can just have it add together the colors of every polygon. The only issue we might have with this is that I'm not sure if Unity will handle the alpha channel differently than the color channels, and if that's the case, then I guess the worst we'd have to deal with is we can only use the red, green, and blue channels of the texture form mask, which would be kind of a shame, but it will still, we'll only have to render once for all lights, so I think it'll be a worthwhile improvement. So just in case this doesn't work, I'll be trying to leave as much of this object intact as I can, so that way we can just uncomment some things. I guess we could always revert the project back to how it used to be, but I think the first thing we need to do is create a new shader. So yeah, we have to do that from Unity. So create shader, another unlit shader, and let's call this additive. Oh no, let's just call this the shadow mesh shader. Okay, so we won't need a texture. Actually, we won't need any properties. And the render type will actually be transparent. And so we'll turn Z test. Oops. Okay, let me see. Is it? I think it's always. Which will make it so that Z test always passes. I think that's what you're supposed to write. I guess we can always try the never. And yeah, we want culling, Z test, and then the blend was the other one. So we'll say blend 1 1, which there's all different ways to blend two channels together. Most of the time when you have a transparent geometry, you want to do source alpha and then 1 minus source alpha right here. But we just want them to add the colors exactly, so we'll just tell it to blend 1 1. I think it should add it. I wanted to see the actual math here. It doesn't say. I'm pretty sure that it adds the two colors together based on this factor. Okay, so blend 1 1. Okay, so here again we don't need fog. We don't need UVs, but we will need a color. Again, here we'll need color. And the color will just pass in from the vertex data. Okay, and all we have to do here is just return the color. And I think that's the shader. Most of the magic is done up here, and it just tells Unity how to handle if two meshes overlap. Okay, so next thing we need to do, oops, compressively float, convert from float 2 to half 4. Oh, yeah, this needs to be a float 4. There we go. And then back in the, let's get rid of some of this stuff. Light mask manager. Actually, it'd be the shadow mesh creator. What we have to do is we have to set the vertex colors now. I think the easiest way is if we have a reference to the color here, and then we'll just pass that in. This will be a little awkward. We'll need to create an array that's the same size as the vertex array. Where do we do that? Okay, it's actually up here. So, and again, since I'm not worrying about garbage right now, I will just continue not worrying about garbage, and we'll just create this new array every frame. And then we just need to set the value here to specific color for this mesh, and then shadow mesh colors equals colors, and that will send this color data to the shader, just like we do with the light mask. Over here is what I was looking for. yeah, we have this mesh color, so it works exactly the same. And then here we need to send the color. So how is it? I guess every 4 lights it switches basically which color. So how would I do this? So color index is I modulo 4. And then we just basically got to send these. So yeah, if color is 0, then it's red. So we'll set 1 to, or we'll set red to 1. Then if color is 1, we set green to 1, and so on for each color. And okay, so let's leave the rest of this code how it is and just kind of see how the game works. Oh, I put a period there instead of a comma. I kind of think the game won't make much sense right at this point, but oh yeah, and then I also need to assign the correct shader to the shadow mesh material. So now it's the 2D lights, shadow mesh shader. Okay, so the only difference now is that well, this mesh is blue. And that's this alpha's mesh, isn't it? So that doesn't really make a whole lot of sense. Oh, it's not though. Okay, so this is invisible because only alpha is 1 in here. Or shouldn't it be black then? Oh, I think we have it on wireframe mode. We can actually... Oh, actually, yeah, these textures don't have... Or the mesh textures themselves don't have anything attached to them. So what is this blue? Oh, I see. Okay, so now the issue is that we need to have a separate mesh. Why is it not doing anything? Okay, so yeah, things are just weird right now. I think we need to convert more of this object. So we only have 1 mesh creator for... Oh no, we do have 1 for every... Oh, I know what the deal is. We only, see, I was thinking we only had 1 shadow creator for each quadrant, but this is actually right. But I think the color here is messed up, so let's see. Yeah, the position should actually... How did this not cause a problem before, or did it? Because the lights go in order. It fills up 1 quadrant and then moves up to the next quadrant, but I think here I actually change the position as if we fill all the reds first. Okay, so cell index is I divided by... Okay, so yeah, we do have 1. That was the problem. We have 1 mesh for every cell, but we actually need 1 now for every cell and color, so we need to add 4 And so now we need to have a separate cell index. Which is I divided by 4. Okay, so that should clear up some of that problem. Not exactly. Okay, so it didn't update line 73. Okay, yeah, it's just because we go through the channel separately. So we still need the mask, but we don't need these single channel textures anymore, and we don't need the combo material. And we don't need split anymore. So basically we'd... it'd be nice if the shadow creator could share the fine segments, like all of them could. But I guess I won't worry about that right now, because right now... Yeah, because the segments are the same, obviously, for every shadow creator, so I should probably pull that part out into a different object, but we can worry about that later. So yeah, basically we'll have the creator create the segment, and then create for its light, which is now basically every shadow has a specific light it works for. And the rendered target. Okay, so we only render once, so we'll put this outside the for loop. And the rendered target is actually the mask texture now. So I can just assign that up here, I don't have to switch that. What's it called? Target texture. Okay, there we go. So yeah, I don't need to set this. Okay, so let's see how this works. Hopefully the visualizer will still make some sense. Interesting. So the visualizer, let's bring this out so we can see it better. It's interesting that there's only green. Aha, and also the mask is exactly where the shadow is, and we need to invert it. So what would be the best way? I guess we can actually return... Well, no, that needs to be like post-processing. So maybe we still will need to call this graphic split, but it will basically just invert the texture. First of all, let's see if it works for the alpha channel. Okay, yeah, so alpha doesn't seem to do, what's the word? Be affected at all. So blue is working, of course obviously the light is, sorry about that, inverted, but that makes sense because the mask is being drawn on the shadow, so we need to switch and basically invert this texture. But it seems okay. This is as I was afraid. Alpha is being handled differently. Even though the color, in the vertex color, the alpha should still be 0. So let's look at the camera. Oh, the background clears alpha to full, so I need to set this to 0. That might be the whole issue. Okay, yeah, that was it. So basically what was happening is the camera set all the alpha bits on the texture to 1, which made everything visible. And so it was basically making the alpha lanterns have no mask, but now they work correctly. Unfortunately now it makes it kind of hard to read the visualizer texture, which makes makes it more obvious why we need to invert the colors. So I guess another way to do this, to make us not have to call an invert shader, is if we actually didn't make a shadow mesh but made a light mesh, which is all the areas that the light touches, which we could do, but the blit is so fast and I don't really want to have to mess with all the shadow mesh code. But I guess if you're going to make this project from scratch again, maybe that's something you'd want to do to not have to worry about having to invert the textures. Just making the shadow mesh seem more intuitive to me. It probably wouldn't really be that difficult. You just have to change most of the winding code in the shadow mesh creator to go the opposite way. Look here. So basically every time that we do a 4 vertices shadow, it would actually be a 6 vertices shadow, and then we'd wind around the other way. So it wouldn't really be too difficult to modify this. Maybe we'll do it, but it seems kind of just like busy work. Okay, so now we need to have an inversion texture, which is very easy to do. Okay, so I want to create another asset, another unlit shader. I'll just call it invert. Oh, I guess invert color. Color, 2D lights. Yeah, the texture will be actually the texture from the screen. Okay, again, we don't care about fog. And yeah, we'll just need UV and the vertex. This is not needed. So all we'll do here is just return 1 minus the texture lookup. And that's about it. So I think on the camera we might be able to add just an invert effect here, and that way we won't have to handle having the material and everything ourselves. So let's go ahead and do that. Invert colors. Okay, so this will be 2D lights. Oh, right. You can't start with a number. What did I call it? Okay, cutout lights. I guess that makes a little more sense. And this is a mono behavior that will be attached to the camera. Oh right, it's spelled with a U. That's not correct. Okay, and all we'll need here is on render image, which is called after the camera renders the image but before it puts it into the final destination. And all we'll need here is, I guess, public material. Well, we could actually do this ourselves. And system material will blit with an unvoid start. This new material and shader. Find 2D lights, invert colors, just invert color. That's about it. So now we just call graphics split on source, destination, and the material is the one we just created. And so this basically we'll just call split like we used to using this shader. And the advantage to using it here instead of back like in our own shadow mesh creator is that we'll just use these temporary textures that Unity already generates instead of having to have our own render texture. And then add this to the camera. Now that I think about it, this callback might actually not be used if you're rendering to a texture already. We'll have to wait and see, I guess. Okay, so yeah, it's not actually doing anything. So what happens if I... Okay, I was hoping... Oh no, I need to remove this. Okay, so yeah, now we can see... Okay, so unfortunately the on-render image is not called if you're rendering to a render texture instead of the screen. So yeah, it looks like we will have to deal with it ourselves, but not a huge deal. Okay. It's a bit of a shame, but it's not what I wanted to do. So this object is not needed after all. Okay, so it looks like we will need to blit again. Graphic. Okay, so I'm going to need to create the material up here. I guess I could have just copied the material I just created here. So the invert material, and then we just call graphics split. So what happens if I don't supply a destination texture? Does it just... I don't think it would like... Maybe it goes to the screen, which is not what we want to happen. I bet that's what it does. But what if I specify the same texture as the source and the destination, which is kind of what we want to happen. I'm not sure if this will work. Okay, yeah, it didn't like that. No, the texture is just all white. Okay, so yeah, we will need to have another dummy texture around. Which is a bit of a shame. Again, this could all be prevented if we... Is there another way? I was gonna say this would all be prevented if we had the shadow mesh creator just create the light mesh instead of a shadow mesh, but I guess it's not a super big deal. So okay, let's have render texture. Okay, and the shadow texture will be just another render texture that will copy all those settings from the mask. And the shadow texture will actually be what the camera renders to. And then we'll blit from the shadow texture to the mask texture using the inversion material, and that should get everything to work how we want. Okay, so first let's these away and look. Okay, so here this looks good. All the lights work how we think they should. And we can see the cyan cut out here, which is wait, that's not. Okay, yeah, the cyan part is the basically absence of red, which is where the this light is cut out. And again, this is just from one draw call and then a simple blit. So I guess let's look at the profiler. Okay, so yeah, this is much faster than before. Before, almost all of the game was taken up by the green color, which is our rendering. But now, this graphics render only takes about 4% of the frame, and then the blit, barely anything. I still think it's funny that the camera that renders the actual game is faster than the one that renders the shadow textures. I don't really know why that is, but I guess probably now there is actually more triangles on the shadow render than the actual game render. So, like I said, if you switched around the shadow mask so they did the light, you could get rid of this graphics blit, which would save 0.2% of a frame. So I guess if you really wanted to optimize, that would be something you could do. But the game worked. I mean, this is... I don't think there's any way we can get the rendering down anymore, because we do basically the bare minimum. One pass for the lights and then one pass for the actual game. Where's this blue one? And now this screen is really messy because you have the lights and then every shadow mesh and then the visualizer texture. It's kind of interesting because these shadows are like the actual colors that we have. Basically, we want to write to the texture, and then it inverts them all. So obviously, you can see here magenta is opposite of green. I'm trying to think if there's some way that you can like have the texture start out white, and then we'd actually subtract. But I don't know if there's like a -1 blend mode. That'd be a little weird. Yeah, they have 0. -1 source color. There's no that one. It probably clamps it actually. I wonder if we set it to 1- source color, and then like set all the colors to 1, and then one specific color to 0. So basically inverted this here. Well, I guess it's worth a try. Okay, so I wanted to retype all those. The order of the 1 and 0 there, I'll just set that to not equal, and then we change the shadow mesh shader to, so it's the source texture -1 source color. Or is it the other way around? Okay, yeah, so the source factor is 1, and then the... Oh wait, no, the source factor is the actual mesh, so that'd be 1- source color, and then destination is 1. So I had this backwards. And I guess this would be subtractive blending if this actually works. I know, for instance, you can do that in Photoshop, but I don't know if you can do that in Unity. Oh, okay, well it has this sub. This actually might be what we want. I guess it's a blend op. I've never used that before. Okay, let's just try this first. Although I guess now I need to turn off the inversion. Let's see here. So the shadow texture will be the mask texture, and then we just turn off this blit. Because we want to actually see. Okay, so obviously something is not right. Okay, so let's try blend op. Instead of adding blended colors together, carry out a different operation. Subtract destination from source. So I think I want to subtract source from destination, so it'd be this reverse subtraction. Okay, so let's see what this does. Let's play around with different blending modes. Oh, here's black. That means that it subtracted the alpha, I think. So if I bring the blue... Oh, I need to set the camera's clear flag. Everything to start full. That might be our issue. Okay, so yeah, something is happening. Let's just see what... Okay, so obviously it works, but it's being... Other info is being masked out. So it's not... subtracting the way I'd want. Okay, I'm just trying to read here. Cutout. Don't want to do that. I'm surprised maybe I'm getting the terminology wrong and it should just be subtract and not reverse subtract. Let's try that out. Oh, is that it? Sort of. This is a little weird. Yeah, it looks like it is working, but what was going on with that one other... this blue one? Okay, so this is blue and quadrant 1. Can't really see. So what is, it seems like it's this magenta part. It's like the magenta is like overriding. So what is, the magenta is green, isn't it? So yeah, it's... Okay, so obviously subtract doesn't work exactly how we'd want. What about this? Yeah, so it's kind of like the color of affects what's already been set. Which is a little weird because all the other colors are supposed to be 0, so when it subtracts it shouldn't do anything. Maybe we could do like min or max. So if anyone is 1 there, then, well, it all starts 1. So if anyone's 0, then we'd add that. So yeah, maybe let's try that. Something's being written, but oh, okay, I guess we just had a bunch of lights inside the colliders. So this seems to be fine. So let's bring in this green and see if it messes up the red mask. Okay, this looks like how we want it to work. And blue. Okay, we can look at the visualize here, and we can see that the colors are blending together correctly. Blue, red, and green are right on top of each other. We get this black. So yeah, they're not overriding each other, which is what I was hoping for, and alpha does not seem to cause a problem either. And if I do something over here, alright, yeah, I knew there had to be some way to do that. So now let's take a look at the profiler. I guess I should turn the other lights on. I was a little scared at first because it looked like there were a bunch of lights not being affected, but it turns out they're just inside the colliders. Okay, so there's still a lot of like fluctuation, and I don't know exactly what causes that. I think it might have something to do with trying to keep a constant frame rate or the garbage collection, but well, it can't be the garbage collection because like it doesn't say it takes up any time, or this is garbage collection. So let's look and see what's going on. Yeah, so we only use about 15% of the time during a frame. The rest of it is just the game waiting for the next frame. And the camera render here only takes about 3.7, so I guess the rest of this time is the mesh generation. So can I do a deep profile? I might have to restart the game, I don't know. Probably. I'd like to get more information about what is going on. Let's wait for that spike to go away. So now we have a lot more light blue. Let's just take this frame. Okay, so 55% of our time is doing the light manager update. Okay, so now the shadow mesh creator takes up a lot more. Now how come? Maybe it's just because I know the profiler does impact performance, but it is a little weird that before like our this shadow light or shadow mesh creator didn't take any time at all, really. Let's look and see. So is segment inbounds takes up by far the most. It's called, I guess it's just called a whole lot of times. Let's look. Oh yeah, because it's called for every segment. And what takes up most of the time in that function? So yeah, it's the fine collision. Surprisingly, this make point takes up a lot, but I guess it's because it has to. I mean, there's ways that we could definitely optimize this, because we don't really need to call make point every time because it keeps checking to see if it's in bounds or not. Where is that function? Yeah, right here. I mean, this is just comparisons, but really, again, all this, I think everything here takes longer now because of the our profiler. Mesh, set vertices. Yeah, this doesn't take much time at all. Add vertices, not really. So find collision does take some time, and it's mostly this mathf approximately, which is a little weird. Calls absolute value that many times. But again, when you do the deep profile, it's more just to see like ratios, excuse me, of time between every function. You gotta kind of take some of this time with a grain of salt, because we saw before when we had deep profiler off, the game was waiting around so much, and now it's only waiting for this small part here, and our script time is much larger. But yeah, obviously there's ways we can improve the crate for light. And this find segments actually takes a lot of time, and right now we call it once for each shadow creator, but we really only need to call it once, and the shadow mesh creators can share it. And that's easy to do. I don't really see a reason to go and fix that ourselves. Interesting. Okay. I guess one other thing we can do is take a look at the frame profiler, which will tell us information about the rendering. So yeah, it renders once. Yeah, so it's rendering the shadows. And now what is this? Now it's rendering all the lights. And then camera. Yeah, so basically we just do, well, it says 10 draws. Is that correct? 9 batches. So let's figure out what is each batch. Wind up. Yeah, this is definitely our meshes. How come they couldn't batch them all together? Doesn't say, does it? Yeah, so now it's clearing the color, the depth buffer, and the stencil buffer. Which, yeah, I guess it needs to do at the beginning of every frame. Okay, so, yeah. If this isn't, it's not going to tell me exactly why it had to batch those out, I don't think. Okay, so yeah, the visualizer takes a draw call, which is obviously not part of the final game. And then it renders transparent geometry. Yeah, so some of these it says why we can't batch, because they have different materials. What is this? Oops, why did I do that? Okay, so first is drawing. I don't know why when I mouse over it changes things. So it's drawing the Okay, I see. So first it draws the sprites, and then it draws the light sprites, and then it draws the lantern. Okay, so yeah, these have to be 3 different because basically the light circles use a different material and they need to be rendered before the rest of the material, so it has to switch, or the rest of the sprite, so it has to switch materials, and that triggers another draw call. So that makes sense. And then if I turn this off, we go down to 4 batches. Okay, no, that was... Obviously if we turn all this off, yeah, that's -2 because it takes the light circles and these little color. Now all these, this shouldn't be... Why did that take away 4 renders? Because they shouldn't even be rendered by anything. Okay, I'm not sure why some of these shadows trigger a different draw call, and it doesn't say. Maybe there's just a maximum number. Because they all use the same material, right? The shadow mesh shader, and there's not any properties in the shader that would trigger another draw call, and the frame debugger doesn't exactly help much. It says it goes to draw shadows and then another dynamic batch, and it won't tell me why they weren't batched together. Maybe it just has to do something with working in the editor. But okay, so now it's down to 2 batches because it's paused. Maybe these extra batches are just from the editor's view and they're not actually drawn in the game. That could be it. It's kind of weird that it would put that out in the frame debugger, but alright, anyway. I think that now we really are completely done with this project because there's no ways we can... Oh, did messing around with these things. Oh, it's paused, okay. I was wondering why the mask wasn't being generated anymore. But yeah, there's no way that we can optimize the rendering anymore that I can think of. Oops. And most of the optimization... Oh, I did it again. I want to get the actual light object, not this sprite. And all the optimization has to do with basically building the shadow meshes. Which, again, is not super hard to do, but we've already worked on that a lot. It doesn't have really anything to do with rendering, so it wouldn't be super exciting, I don't think. So, I think we're done with this project. I still have a little time left, but I don't think I have enough time to really start back on the Lizard Tamer game, which we will definitely work on tomorrow. So yeah, I guess we'll just have a smaller stream tonight to finish up final loose ends here, and yeah, so now I'm really happy we got everything down to just 2 renders. Feels really good. I'm gonna a little embarrassed I didn't figure out this with the blend modes before, and we messed with all those combining textures in the render texture, but it was still a good exercise, I guess, to learn more about the blit operation and render texture, so not a complete waste. But anyway, again, thanks everybody for coming by and watching, and I hope you've enjoyed this 2D Lights project. Next time we'll go back to the Tactical Lizard Tamer, a large project I've been working on, and I think I'm going to start still working with graphics. I think I'm going to try to create a map, a pretty looking map, almost like Civilization style. Of course, it's going to take quite a long time because that map also needs to be moddable to add new terrain types, and yeah, that is going to be fun for sure. But again, if you miss any of this series of streams or any of my streams period and you want to catch up, I do upload everything to YouTube, so you can get there either from my channel description or by typing !YouTube in chat. I also have a Discord channel if you want to chat with me throughout the day, and other viewers. We'd really appreciate you there. You can get there by typing !Discord in chat or by looking in this video description or my channel description. And also feel free to follow me here on Twitch or even Twitter if you want to. I do try to talk to viewers, so always appreciate messages. And yeah, I guess that's it for me. I hope you all have a great night, and I'll see you tomorrow. Alright, bye-bye.